Hello everyone, welcome to Concepts in Chemistry YouTube channel, and also welcome to our new series, that is Chemistry Concept Booster series. So guys, I thought that before Barc exam, Barc first phase exam that will held on 2nd April. So I will not upload more videos before Barc first phase exam, but yeah, today afternoon I realized that okay, let's discuss on more questions in chemistry concept booster series, so from statistical thermodynamics. So let's discuss on questions from statistical thermodynamics, and let's revise some formulas, and in this way you can revise some concepts from statistical thermodynamics, uh, and also by solving this problem you will gain some different concepts from statistical thermodynamics. So let's start. So in this questions, chemistry concept booster 17, we already uploaded 3 questions, and there we discussed 16 questions, 6 from physical chemistry and 10 from organic chemistry. So this is chemistry concept booster 17. So the most probable distribution for arranging of Na and Nb atom in a mixture is. So most probable distribution for arranging of A atoms means there are two types of atoms, A atoms and B atoms. So A atoms, number of A atom is Na and number of B atom is Nb. So the most probable distribution is they are asking about the thermodynamic probability, or you can say the W term. So the most probable distribution is the thermodynamic probability, or we can say the W term for we use for most probable distribution, W term. So in this question we have to find out the W. So let's see the answer and discuss some concepts from statistical thermodynamics. So in the question given, there are two types of atoms or molecules given, Na and Nb. We have to find W, that is thermodynamic probability. So we all know that for a particular distribution, if you already read that statistical thermodynamics, this is the basic concept or basic primary concepts from statistical thermodynamics. So for a particular distributions, if there is N1, N2, N3 types of particles or populations, these are different populations, N1 types of populations, N2 type of populations, N3 type of populations in a particular distributions, then for a non-degenerate system, the thermodynamic probability, or you can say the arrangements, how many way we can arrange these particles, so that is also called as thermodynamic probability. So that is normally usually the most probable distribution we call thermodynamic probability. So thermodynamic probability is W equal to n factorial. So n is total number of particles. So n is total number of particles. In this case, n is equal to n1 plus n2 plus n3 equal to summation of ni, and n1 is different type of particles or populations present in the mixture. So the formula is n factorial divided by n1 factorial into n2 factorial into n3 factorial. This is for non-degenerate system. So as we write normally, usually write summation for summation for sigma term, sigma ni is capital sigma. Same for multiplication, we write pi ni factorial. So if there is pi ni factorial, it means n1 factorial into n2 factorial into n3 factorial, so on. So we write normally multiplication we write capital pi. So this is pi, not capital pi. So for degenerate system, only one term extra should be there, that is degeneracy term. So pi gi factorial, ni pi ni factorial, ni pi ni factorial is same. For degenerate system, this is for non-degenerate system, this is for degenerate system. Pi gi means in this case additional is additional term should be there, like in this way, g1 factorial into g2 factorial into g3 factorial into so on. That's why we write here pi gi factorial, pi gi factorial. So this formula is for non-degenerate system. N total number of particles means summation of n1, n2, n3 upon pi of ni factorial. N is different particles present in the mixture. So for degenerate system, n factorial upon pi small ni factorial into pi gi factorial. So in this case, we have to consider the non-degenerate system. So since there is no in the question there is no mention on degeneracy, so we have to consider the non-degenerate system. So now in the given case, so n means total number of particles, total number of different type particles, Na plus Nb. So we can write W, that is thermodynamic probability or most probable distribution, like way we see here n factorial by n1 into n1 factorial into n2 factorial into n3 factorial. We can write pi ni factorial. So since there are two types of particles present, we can write Na plus Nb, that is n factorial upon Na factorial into Nb factorial. Now if we take ln both side, then ln W equal to ln Na plus Nb factorial minus ln Na factorial minus ln Nb factorial. Now we have to keep in mind one formula, that is called Stirling approximation formula. So I think many of you already know this formula, and those who are unaware of about this formula, so this is an approximation formula. We can use any logarithm ln if ln is there and is factorial term is there. So this is Stirling approximation formula. Ln n factorial, we can write n ln n minus n. Just ln n factorial, this factorial term will be out. We can write this term will go first n, then n ln n ln n minus n. So if there is factorial term, don't confuse with this term. This n and this n can be different. I normally wrote same as n, so you can write here p factorial. So these functions, if there is like function ln n factorial is n ln n minus n. If n value is very large, if the value of n is very large number, then this formula gives a better result. So in this case we are considering gas molecules. So gas molecules, so if we consider only 1 mole of molecule, then there are Avogadro numbers of molecule, means 6.023 into 10 to the power 23 molecules. So that's why we can use this Stirling approximation formula in this case, in all the thermodynamic cases, because we are considering gaseous molecule, and if we consider only 1 mole of molecule, then there are so many of molecules, so we can use Stirling approximation formula. So this formula gives better result when n become large number. So keep in mind this formula. This is Stirling approximation formula. Ln factorial something factorial is equal to n ln n minus n factorial. So now this is, if we use Stirling approximation formula in this equation, then what we will get? We will get first Na plus Nb. See, we used here, first consider this as a ln n factorial, this whole term consider as a n. Then what we can write? Na plus Nb ln Na plus Nb minus Na plus Nb. Similar, Na plus Nb ln Na plus Nb, this term should be there, minus this term minus ln Na. So what will be there? What will be the approximation? Na ln Na minus Na. So minus Na ln Na minus Na. Same thing for ln b factorial, nb ln nb minus nb. Same thing for nb. Here is no chemistry, so chemistry is the Stirling approximation formula and the thermodynamic probability. We have to consider the thermodynamic probability, and that is chemistry. But this is only a mathematical calculation, properties of some logarithm functions. Just this is a mathematical calculation. So we are just rearranging the whole term here. So just we are trying to rearranging. So now this, so Na plus Nb ln Na plus Nb. So we can write this whole term. So this whole term we can write ln Na plus Nb power Na plus Nb. Since this term is before ln, we can write this term power of this term. So ln Na plus Nb power Na plus Nb, we can write this term. Now minus Na plus Na plus Nb. If we multiply minus with this Na, then it will become plus Na. If we multiply minus with this minus Nb, it will become Na plus Nb. So minus Na plus Nb, and after this step we can write plus Na plus Nb. So this become plus and this also become plus Na plus Nb. So this Na plus Nb will be cancelled out. Now what will be the rest? Minus Na ln Na minus Na ln Na minus Nb ln Nb. From this minus Nb ln Nb. So this is just a mathematical calculation. So we can write also this term ln n to the power this Na minus ln. So this term is before ln term, we can write power of this term Na power Na. Same thing for Nb. So now ln A minus ln this term. So just consider this whole term as a x, ln x plus ln y, nb to the power nb, you can assume y. So ln x plus ln y, we can write ln x into y. So if there is summation term in ln, we can write the function in the bracket into multiplication form. So ln x whole term plus ln b whole term, we can write ln a plus ln x into y. So now ln this term is ln a minus this term is ln b. So ln a minus ln b we can write as a division format. So ln a by b. So now if both side ln, if we cancel both side ln, then w equal to na plus nb to the power na plus nb upon na to the power na into nb to the power nb. So this is just the mathematical calculation. In the previous case, we have to we used the Stirling approximation formula in these three cases. First case, second case, three case, we apply this Stirling approximation formula. Stirling approximation formula we can use where the n value means this value is very high, this value is a large number, then this approximation give a better result. So we saw here the equation of thermodynamic probability for degenerate system, for non-degenerate system. This is for non-degenerate system, this is for degenerate system. So now, so the options Na plus Nb to the power Na plus Nb upon Na power A, Nb power Nb. So in the lower term, means this term show multiplication should be there, not positive sign. So C, D are cancel out because in this term. So so in the so we saw here that that in the denominator there is this two term is in multiplication form, so in a multiply form, so that's why, so these options are not correct. So from these two options, so these two are multiply form, these two also in multiplication form, so na plus nb, here the power is not, in this case the power is not here, so na plus nb, power na plus nb upon na to the power na, nb to the power nb, so the correct option is B. So I hope you guys understood this different questions from statistical thermodynamics. So this will not only for Barc or GATE NET exam, so this type of questions may be asked in different type of MSc entrance exam. So I think this video will be very helpful for all of you. So thank you for watching, and so stay safe, stay healthy.